Now we're going to look at finding a confidence interval for a mean. Reading through this problem, the first thing I need to do is figure out which parameter I'm looking at. And what it says here is that I'm trying to find a confidence interval for the true mean cholesterol content of all the eggs. This is the keyword I'm looking for. If I'm going to do this in StatCrunch, that tells me that I'm going to be using t-stats. We always use t-stats in StatCrunch if we're talking about a mean. The information I have is that they tested 41 chicken eggs. That would be my sample size. My sample mean would be 193. And it also gives me my sample standard deviation is 15.4 milligrams. And I want to do a 95% confidence interval. I'm going to need all of those things to use my StatCrunch procedure. In StatCrunch, what I want to use is stat, t-stats, one sample. Since I don't have a data set, I just have summary data from the sample I'm using with summary. It's going to ask me for all of these values. My sample mean is 193. My sample standard deviation is 15.4. My sample size is 41. And I want a confidence interval with 95% confidence, so I'm going to leave that as 0.95. When I click on compute, it should show me back the sample mean. That should agree with what I had already. And it has my lower limit and my upper limit for my confidence interval. If I want to write this in interval form, that would be 188.1 up to 197.9. If I wanted to write it in this form, where I have the point estimate and the margin of error, my point estimate is my sample mean. That would be 193. For my margin of error, I'd have to take my point estimate and figure out how far it is to either one of the two limits of my confidence interval. For example, I could take 197.9 and subtract 193, and that would give me my margin of error. And that would be 4.9. To write my confidence interval in this format, I would have 193 plus or minus 4.9. In this question, we're doing a new study, and it asks how many eggs we have to test in order to estimate the cholesterol content. So what it's asking us to find is a minimum sample size. It's important in this one that we're talking about a mean. The formula is different than it is for proportions. What this formula looks like is it's z of alpha over 2, that's our critical value, times our estimate of our standard deviation over our margin of error, and that's all squared. And for this one, notice that this is a z. So if we have a 95% confidence level, this is one of those standard ones that we use a lot. The critical value for 95% from the z distribution is 1.96. We already have that one. And it says in this problem that we're going to use the previous study to estimate the standard deviation. In the previous study, the sample standard deviation was 15.4. That's what we're going to use for our estimate. And then for the margin of error, in this one we're not talking about percentages that need to be changed to a decimal. We're going to use whatever they gave us. They asked us to estimate the cholesterol content to within 3 milligrams. Within is a key word that tells you that they're talking about the margin of error. So our margin of error is 3, but it's just 3. It's not 3%, it's just 3. For our formula, we're going to have 1.96 times 15.4 divided by 3, and that whole thing is squared. That gives me 101.2. Since this is talking about a minimum sample size, I have to round this up to the next whole number, which means I'm rounding it up to 102. And that's my answer for the minimum sample size. Now we're going to look at constructing a confidence interval for a standard deviation. This is very important that you know which parameter you're constructing a confidence interval for. This one's for a standard deviation. That means in StatCrunch, we have to use the variance stats. There is no procedure in StatCrunch to do the standard deviation directly, so we have to use variance stats instead. The fact that we're using for that is that the variance is equal to the standard deviation squared. Or you can think of the standard deviation being the square root of the variance. If we can find a confidence interval for our variance, then we can take the square root of those values to get the confidence interval for a standard deviation. So here's the information from the sample from this problem. So we had a sample size of 41, a sample mean of 193 milligrams, and a sample standard deviation of 15.4 milligrams. We want to do a 95% confidence interval. In StatCrunch, we're going to choose the variance stats, one sample with summary. Since we don't have a data set, we just have summary information from the sample. Here's where you have to be very careful about what numbers you're putting in. Notice what it's asking for. Right here is the sample variance. We don't have that, we only have the sample standard deviation. But because the variance is the square of the standard deviation, we can get the sample variance by taking our sample standard deviation and squaring it. Our sample variance would equal 15.4 squared. And that is 237.16. That's the number that we'll put into StatCrunch. Our sample size was 41. Then we're doing a confidence interval, and we want this to be 95% confidence, so I'm going to leave that as 0.95. The results I get here, notice they show me the sample variance, not the sample standard deviation, and my lower limit and upper limit, those are both for the variance. So my confidence interval for the variance is 159.86058 to 388.26115. I'm writing down this many decimal places because I'm going to take the square root of this, so I don't want to round these before I take the square root. From that, I'm going to go to my confidence interval for the standard deviation. That means I'm going to take the square root of this number to get my lower limit for this confidence interval. That gives me 12.6, and now I can round that value. And then to get my upper limit here, I'm going to take the square root of my upper limit there. And that is 19.7.